way to maintain a good security posture is to have everyone understanding exactly what level of security you should have in your organization. And you can do this by creating formal security policies. This will be the starting point so that everybody knows exactly what devices need to be secured and how you're going to have that security put in place. This is usually something that's well documented. You're sitting down and writing a very formal document that describes security from the very beginning to the very end and everything in between. It's the management of an organization that decides what needs to be secured. It's then up to the IT department and the security teams to implement a security structure that's going to provide that security. Security policies will often define what you need in place to prevent an attack from the outside. You may have a security policy that specifies what types of firewalls and where they will sit in the organization. There might also be intrusion prevention systems or other types of security components to help against those attacks. You might also have security policies that specify how malware will be protected against. So you might require antivirus software. There might be a need for a proxy server inside of your environment, or you may need real-time network scanning in your firewalls themselves. You might also have part of your security policy revolve around password security and training of your users. They're often the weakest link when it comes to security, so you want to be sure they're as knowledgeable as possible of the expectations that are on them for the security of the organization. And if people are outside the organization and they need access to your internal resources, you may need security policies for remote access. This policy might include VPN software or multi-factor authentication or anything that would allow you to confirm that the people connecting to your network from the outside are absolutely authorized to do so. If you're running a web server or an email server or a file server or some other type of service, you're going to need to open up ports in your computer. Normally, when you start the service, it begins listening on a particular TCP or UDP port. You have to at least open that port up so that other people on the network would have a way to access that service on your computer. The port is usually very specific to a particular service. So if you start a web server, it's probably listening on TCP port 80 and TCP port 443. If you're opening other types of services, they will pick other available ports to open up on your computer so that other people on the network can access that service. The people accessing that service should be connecting to that port and only accessing service information that is specific to them. They would not necessarily have access to anything else inside of your computer. But every time you open up a port, there's the potential for some type of problem. Some applications are developed poorly, or they might have vulnerabilities that might allow people access to things that normally they should not have access to. That's why you should always check for updates and make sure that all of your applications are up to date. You don't want to start a service, have that port open up in your computer, and then have somebody connect to your computer and misuse that service to gain access to your entire system. Here's visually how this works. You have devices on the network that are accessing servers that have open ports. You have a source port that you're using to be able to communicate to that device. And then these are the open ports that are always available. They are what we call well-known ports because those are the ones that are commonly associated with those types of services. This is a web server that is not only using TCP port 80 and TCP port 443. So those are ports that are always open and always listening for users. It looks like this server is also providing DNS services, so you can see an open port over UDP. Port 53 is open to provide those DNS responses. There are a number of different ways to examine what port numbers might be running on your particular system. I grabbed a Windows machine and ran the simple netstat-a, and that gave me a list of all of the open port numbers that were listening on this particular device. You can use other netstat parameters to tell you more information about what process ID might be associated with that particular open listening port, or perhaps what the name of the executable is that's providing that open port. There are, of course, a number of third-party utilities you can use to provide similar information. This is one from Nearsoft that is CurPorts, C-U-R-R ports. and you can see that it shows you similar information, shows you process ID, protocols, shows you the name of the port that happens to be open. By using one of these utilities, you can get additional information about what ports might be open on your device and what applications might be associated with those ports, and then you can make a decision on whether that port should stay open or whether it's an interface that you can close off to the rest of the world. A number of network services use built-in usernames and passwords to be able to access these services. So it's useful to know what usernames are configured in your operating systems and which ones might be in use and not be in use. And it changes depending on what operating system you're looking at. But generally, you're looking for usernames that might be guest or root or mail or something associated with a particular service. Not all of these accounts are going to be necessary to use these services, and not all of these accounts need to be in your system if you're not planning to run those particular services. So you should disable or remove those particular accounts if you're not going to need them. Another thing you might want to consider is disabling the ability of these accounts to log in interactively. This means that only a service would be using these particular account names, and no one else from the outside would be able to connect to your computer and use one of these account names to gain access to your system. If you spend any time looking at packets going across the network, then you know there is an amazing amount of information inside of them. Sometimes there's more information inside of them than we even realized. There might be some personal or private information that goes across the network, and that's certainly something we need to be aware of when we're communicating on an unsecure network. It's very easy to pull this from the network, and even easier if it is a wireless network. So easy to pull those packets right out of the air. If you're at a coffee shop, you'd be amazed at how much information is floating around in the air from everyone in that coffee shop who's using their mobile devices. That's why we always recommend that you use encrypted protocols, you use a virtual private networking tunnel, and do everything you can to encrypt all of that data so that if someone was to look at these packets, they wouldn't be able to understand anything that was going by. Let me give you an example of how you might do this with something like web browsing. Here's a protocol decode that contains information going from a client device to a web server, and it seems to be posting information from a form. You can see that the summary up top shows this post command /general/status.html. And if we look into the detail of this particular decode, you can see that there is a form item B531, and the name is super secret. We could easily pull that information right out of the posting that's being done to the web server simply by looking at the traffic going across the network. If we didn't want somebody to see this information that we were sending, even though it was super secret, we could simply use a protocol like TLS. This is the SSL type protocol that you would commonly see when you're using a browser, and it has the little encrypted lock at the top of the screen. Everything going back and forth then has just application data inside of it. The protocol decoder can't see anything else. If we look at the detail, you'll even see that we can't even tell anything about the application data. And if we even examine it, we can see it's just a bunch of numbers and letters. It's all a bunch of hexadecimals shown on the screen. There's nothing there that would give us any detail about what might be inside of this traffic flow. You can see how easy it is to get information right off the network in plain text. So we always need to be aware of the protocols that we're using over the network, and we want to be sure we're using the ones that are secure. Let's look at SSH. SSH stands for Secure Shell. If you're someone who is doing a lot of console connections to infrastructure devices or to Linux devices or anything that needs that console terminal screen, you want to use SSH instead of using Telnet. Telnet would be in the clear. SSH would be an encrypted communication. SFTP is a very similar scenario where you're using SFTP, which is a secure file transfer protocol, instead of FTP, which is an in the clear or an unsecure file transfer protocol. And interestingly enough, SFTP is simply using SSH to provide the encryption for that file transfer. If you're someone who is working a lot with network management, then you're probably using SNMP, which is the Simple Network Management Protocol. There are a number of different versions of SNMP, but only SNMP version 3 provide the encryption and protection of that information going between you and those remote infrastructure devices. We mentioned also earlier the web communication, which is SSL or TLS, transport layer security. You may hear this referred to as its legacy name of secure sockets layer. If you're doing web traffic, instead of looking at it in the clear, why not use HTTPS, which is going to provide that extra encryption right on top? And if you really want security over connections, perhaps between different locations, you can send everything through an IPsec tunnel. This stands for Internet Protocol Security, and it effectively takes all of the information going from point A to point B and sends it through a virtual private network in this encrypted form. These protocols would be a very good starting point, but you always want to check to be sure the applications that you're using are not sending anything out over the network that might be in the clear. There are many different ways to filter information as it's passing through the network. If you want to keep your network secure, then you're going to want to take advantage of access lists. A content filter includes a set of access lists that determines whether information is allowed or blocked, and it's usually making this determination on what is inside of the packets themselves. In large organizations, you commonly see content filters being used to allow or disallow information going from the inside to the outside or vice versa. Perhaps you're preventing sensitive materials from being transferred out of your organization. Or maybe you're using content filters at home to prevent inappropriate information from being shown in a browser. These are very useful for things like parental controls. You can also use access lists inside of your content filters to prevent anyone from going to known bad websites. There are a number of websites out there that do nothing but provide malware and viruses for your computers. So by simply adding one additional URL entry in your content list, you can prevent anybody from visiting these bad sites. A very common type of access list in a content filter is a URL. This stands for Uniform Resource Locator. You might also hear it referred to as a URI or Uniform Resource Identifier. These URL filters are designed to allow or block based on what the URL happens to be. That's the only content we're really looking at is what's in the address bar that's being sent out. These lists are generally managed by category. Instead of you having to know every single URL and manage all of them individually, you simply roll them up into broad categorizations such as auctioning, maybe known hacking sites or known malware sites, travel sites, recreation sites. You have complete control over what categories are allowed and what categories are blocked. URLs are, of course, just one particular criteria that you could use, but you could set up some very broad access lists that might allow or disallow access to particular sites. You should be aware of the technology used in your URL filter. Some do a very good job at blocking encrypted data, while others have no visibility into anything going across the network that might be encrypted. You'll need to check with your URL filter to determine how much of this information it's really going to be able to see. The access list inside of a firewall can be based on a number of different criteria. It's common to see these groupings of criteria, which we call tuples, being things like a source IP address, a destination IP address, a port number. It could be time of day or a particular application in use. And you can use any one or a combination of these tuples to determine, do we allow information to pass through the firewall or do we block it right at the firewall? The access list in a firewall is usually something that is evaluated from the very top, and then it steps through the list all the way to the very bottom. So as traffic is coming into the firewall, that packet is evaluated across the first item in the list. If nothing matches inside of that item, it goes to the next set. If nothing matches in that one, it goes to the next set. And it goes through each one of these access lists until it finds one that matches this particular kind of traffic. And then there's usually a disposition of that access list that says that this